my Algebra 2 friends. I'm coming to you here from my basement toy room because that is the only quiet place in my house right now. So this is our lesson on 1.3 part 1. This is algebraic expressions, and it's actually our first official lesson in Algebra 2. So let's get some vocab back into our brains after our long summer here. So if you have 2 to the 5th power, some vocabulary there. 2 to the 5th power, 2 would be your base, and 5 would be the exponent. And we know that 2 to the 5th power, I'm just going to turn off my audio. 2 to the 5th power means 2 times 2 times 2 times 2 times 2, which of course we'd be either going from memory or using a calculator because no one wants to compute that, although we could. It is 32, by the way. So let's try some examples here on our own. We have x times y times x times x times y. So the shorthand way to notate that using exponents would be x to the 3rd power times y to the 2nd power. And there's no way we can simplify that. You can reverse the order if you'd like, but technically in math everything likes to go alphabetical unless there's some weird rule in the form. So here, for example, b, we have 6n times 6n times 6n times 6n. So you have 1, 2, 3, 4 of those 6n's. What's going to be important is that you use parentheses before you use the exponent of 4 to indicate that both the 6 and the n show up 4 times. And then there's a minus 3 term in that expression. There's nothing to collect, I guess, with the minus 3 term, and there's definitely no multiplication there. This is a really important idea. When to use parentheses and when not to use parentheses. So if you use parentheses around the -3 and you raise that to the 4th power, you're taking a negative times a negative times a negative times a negative. And remember in math, if you have an even number of negatives multiplied together, that becomes a positive value. So if you were to type this into your calculator just as written -3 to the 4th power, you would get a positive 81. As opposed to right here, if you type -3 to the 4th power without indicating parentheses, your calculator thinks that you have just a -1 coefficient out in front, and then you have 4 of the 3's multiplied together. So this right here is an 81, and then if you throw a negative coefficient in front of that, this would give you a negative 81. So a lot of times we see in algebra class, raise hands in the air, a kid going, "Oh, my calculator gave me the wrong answer." It's the contributor to the calculator that's doing it wrong. So we got to be careful. Do we want parentheses or do we not? Which brings us to another idea. PEMDAS, or please excuse my dear Aunt Sally. This is the order of operations that you've been working with for quite a few years now. And this is what your calculator follows as long as you type it in correctly. But surely we can do this without a calculator. And my friends in Algebra 2, there's a very good chance that you'll be taking your SAT test in the near future. And there's a huge chunk of the SAT test that is non-calculator. So you got to make sure you can do some basic computation without a calculator. Plus, sometimes it's just cumbersome to have to bring out a calculator. So parentheses is the first part of order of operations. And when I look at letter A, there is a problem within a set of parentheses right here. And that says -2 plus 5, which is actually a 3. So this really says 3 to the 2nd power. And then there's a 2 in front of that. Being multiplied, that's a multiplying sign, hello. And then there's a -4 in front of that that's being added. So the next thing we'd have to do in order of operations would be your exponent. So right here, we've got 3 to the 2nd power, better known as 9. And then there's still that 2 in front of that. And then multiplication would come next. 2 times 9 is 18. And then -4 plus 18 would give us a 14. So the idea is now that we're in Algebra 2, we should be able to do those kind of quickly, but these are places where kids tend to mess up if they're going too quickly or they're not thinking about it, especially if it's written in a way where it kind of tricks your brain. I see a lot of these on Facebook, like, who can get the right answer? I bet no one. And then turns out, yeah, no one can get the right answer because no one understands how to do it. So right here, be careful. This is -5 squared, but that negative is not included in parentheses, so you're not squaring the negative. So watch out for that when it gets to that part. But 2 minus 6, this guy right here would be a -4. Now that, because there already are parentheses around it, that's like the singular value, -4. When I go to square that one, I do square the negative, so be careful there. And then, so right here, exponents would be next. Be careful though, because like we were just saying, this guy squared and this guy squared have two different things going on. So I'm going to leave the negative in front as a coefficient, and then 5 squared is a 25. Apparently I forgot how to write over the summer break. This is my first lesson I've recorded in a few months. Alright, so we got a 3 here, and then negative 4 squared would be negative 4 times negative 4, so it would be a positive 16. So we're multiplying by a positive 16. So multiplication would come next. These guys get multiplied together. This is a 48. So we have negative 25 plus 48, which I should totally be able to do in my head because I'm a math teacher. I think it's 23. Now, that problem, knowing what I know now about it, if I was on my SAT test and I had a calculator handy, or if I was just doing homework, or if I was just computing something for somebody, even I would probably grab my calculator. And here's the cool thing about your calculator. It has what's called horizontal script format, and it does order of operations. So if you were to type that problem in exactly how it looks, so negative 5 squared, no parentheses there, plus 3 times, and then in parentheses, 2 minus 6 outside the parentheses squared, you'd get the right answer. You'd get 23, because your calculator is programmed to follow order of operations. Now this one, we'd have to be careful. If you were just to grab your calculator right now and type it in, which I know is very tempting, if you typed 8 minus 3 and then you divided by 3 plus 2, your calculator is going to do this 3 divided by 3 first because that's what you told it to do. If you wanted it to group the numerator and denominator separately, you'd have to tell it that, because remember, it's horizontal, so it doesn't know that this is a numerator and this is a denominator because you didn't tell it. So there are what are called implied parentheses when you have a vertical fraction in math, and your calculators, since they don't type vertically, they type horizontally, you got to remember to put those parentheses in. So Mr. Abruzzo just took some college classes, and I'd constantly remind him when we were doing homework, like, oh, don't forget your parentheses. And he just got to the point where he was so paranoid, he just put parentheses on like everything. So a little overkill, but it worked. So keep that in mind. Oh, I didn't answer that question though. Back up. All right. So if we answered this question, I could probably do this in my head, right? That's a 5 and that's a 5. So 5 divided by 5, better known as 1. Yeesh, I really can't write. All right, here we go. Another task that we're going to ask you to do with an algebraic expression is to evaluate it. So the words that, back in the day we'd use, your teacher would tell you to plug in a value. So an algebraic expression has some unknown variables, x and whatever they're using. And then sometimes they tell you, let x be this. And then that means you're supposed to evaluate it or substitute it into the expression. Great. I love this. We can do this. So negative 3. And then a good math teacher trick is anytime you have a variable and you're going to remove it and put something in place of it, just put parentheses around it, because that is always a safe thing to do. All right, so right here it says use x equals negative 2. Oh boy, this would be a good candidate for grabbing a calculator. If you were to grab your calculator right now and crank all this in the calculator exactly how we just wrote it down with the parentheses and everything, you're going to get the right answer. The kid who doesn't put parentheses right here around the negative 2 squared, that's where the mistake happens. But, since I'm a little bored this summer and I need to stretch my brain a little bit, let's do this in our head. So order of operations, there's nothing within the parentheses to do first, but we do have exponents that we need to take care of right here. So negative 2 to the second power is a positive 4. And that still has a negative 3 in front of it that we're going to multiply. Speaking of multiplication, we got another one here. So negative 5 times negative 2, which I'll take care of in a minute on the next line. All right, let's talk about multiplication. We've got negative 3 times negative 3 times 4, which is negative 12. And then careful on the negatives, negative 5 times negative 2 is positive 10. And then plus 7. And again, math teacher, I should be able to do this, right? Negative 2 plus 7 is a 5. Same answer a calculator would have given us. I'm not going to judge you if you use your calculator when it's handy. Definitely not going to judge, okay? Do what you need to do. Another thing we might ask you to do with algebraic expressions is to clean them up or to combine your like terms and simplify them. So notice we're calling these algebraic expressions. We are not solving anything yet. That's going to be in our upcoming lesson. We are just simplifying right now. So we look for what are called like terms. This example here of 2x plus 4, there are no like terms. 2x is a variable component plus 4, which is a constant. They are not the same type of term, therefore you cannot add them or subtract them together. You could multiply unlike terms or divide unlike terms, but we're not going there yet, okay? So when we look at this example, we see some like terms here, and sometimes I just tell my kids, think about smushing them together. So 3x and then a minus 2x, if I smush those together, that would be a positive 1x, which I would just write as x. And then here we got a plus 7 and a plus 8. If I was to smush those together, that would be a plus 15. And there we go. Simplified answer, x plus 15. We'll learn later on that polynomials, we like them in what's called standard form. So they would go in alphabetical and decreasing exponent order. So x would come before the 15, but if you wrote 15 plus x, you're totally fine. So here's some more examples. We're going to be combining like terms. Very similar problem here on number 1. Be careful though, it has to be the exact same variable, including the exponent. So the 3n squared and the minus 1n squared, those are like terms that you could combine together. That's where you get the 2n squared. And then you have this plus 1n, there's nothing to combine with it. So I just kind of write it off to the side here. Man, I hope I figure out how to write before we actually start school in August. Okay, number 2. Oh, we have what's called the distribution property. So this 4x is going to be multiplied into every single term that's inside of the parentheses. So here, since we're multiplying them, they get to multiply with every other type of term. It doesn't matter whether they're like or not. So when you take 4x and you multiply it by 5x, you do get a 20, and then x times x would be x squared. And then 4x times positive 4 is a positive 16x. Now don't forget, there's this extra term over here. Sometimes I finish these too fast because I'm not looking. And now we have like terms. So you have that 16x and then a minus 18x. Those are like terms. We can smush them together. And that gives you what, a negative 2x? But don't forget you have the 20x squared in the problem. So this would be my answer. If you have a different order, that's totally fine. Sometimes I get kids saying things like plus negative 2x. That's fine. It's just kind of weird. That's all. Oop, why am I switching slides? I'm not done yet. Let's take a look at, this guy's a little, oh well, cut off my problem. I don't think there's anything after that 4 other than a parenthesis. So let's distribute. Here we have a 2 being distributed. Be real careful on this last part though. This is a negative 3 that's being distributed into that problem. So this is a 2x plus 2. And then a negative 3x. And then here the negative become a plus 12. All right, so we're just combining our like terms. I see some x terms right here, 2x minus 3x. If I were to smush those together, that becomes a negative 1x, which I'll just write as negative x. And then here you got a positive 2 plus a 12. If I were to smush those together, that would give me a plus 14. I got some really interesting colors going on today, guys. Sorry about that. Oh, it's 4th of July this week coming up for me, so I'm sure you're not watching this on 4th of July week, but it's okay. All right, here's some more evaluating. We're going to be really tempted to come and grab our calculator and do the evaluation. I encourage you to do that, especially as you're practicing this individually. I love that you guys do mental math, and then I really love it when you check your answers, especially for testing. Or if you're just, checking the key on your homework and you're like, man, I did not get the right answer. If you did mental math, just whip it into the calculator real fast and see if that's where the error occurred. If it's something else, then we can talk about it. All right, so we have x to the 4th power plus 3 times y. And they want you to evaluate when x equals negative 2 and y equals negative 8. So remember, anytime I take a variable out when I'm putting something in, I'm going to use parentheses. So like right here, we have x to the 4th power, but they just told me to use a negative 2 instead of x. And then a plus 3 times, instead of y, I'm supposed to use a negative 8. Now, if I were to crank that into the calculator exactly how it is written, I'd get the right answer. I actually don't have a calculator handy and working right now, so I'm going to use the old noggin here. Negative 2 to the 4th power, that's going to give me a positive result because it's even powered. 2 to the 4th is 16, so 16. And then positive 3 times negative 8 would be a negative 24. And if I did 16 minus 24, that would be a negative 8. Awesome. All right, so see, we can do it without a calculator. It's just not fun. Number 5 again, I'm going to use parentheses whenever I am putting something in place of a variable, especially here where they're trying to trick me. So x squared is really supposed to be a negative 3 squared with parentheses, notice. And then divide by, let's see, what's the other variable? Y equals 2. So 2 times y plus 1, which would be 2 times 2 plus 1. Now here, a word of warning. If you were to use your calculator and you type it in like you see it right now, you're going to get it wrong because it doesn't know that your denominator is one whole denominator. The numerator's fine because it is just one number. Negative 3 squared it knows that as a singular unit. But you would have to use parentheses on your calculator like this. After you hit the division sign, you'd have to hit parentheses 2 times 2 plus 1. And then there's nothing wrong with using a hybrid approach. Like, you know, sometimes some operations are really good for me in my brain and some are not. And like for me, subtraction for some reason always messes with me. So like I'll do all the other operations and then like, oh, if it's a subtraction problem, I always double check myself on the calculator. That's fine. All right, so here we got negative 3 squared would be a positive 9 because again, we have an even power. And then this is 4 plus 1, which would be a 5. Now, notice in the instructions it says if it's a fraction, leave it as an improper fraction. Don't go to decimals, don't go to mixed numbers, but make sure it is a reduced fraction. So on your calculators, the fancier ones we're using, the TI-84s, that's where you can type it in, whatever it is, and then hit math, enter, enter, and it'll always bring it back to a reduced improper fraction. Math, enter, enter is your new favorite friend. All right, let's take a look at, oh man, a good geo review. So, short history lesson here, guys. This is being recorded in the summer of 2020. So I don't know when you are watching this video, but if you remember what the summer and spring of 2020 looked like, it was a very tumultuous time in our lives. So all of my Algebra 2 students here in the school year for 2020-2021, they had e-learning for like the last, few months of school back in spring 2020. And if you didn't get a great experience during e-learning, or maybe like life was really bad and you didn't get all of the learning out of school that you were hoping for, my kids missed the entire chapter on area, perimeter, and volume formulas, which was kind of important, for everything else in life. So we want to make sure that when possible, we infuse that back into our curriculum. So don't be surprised when all of a sudden all these geo problems keep popping up. They're going to have an algebraic twist to them, don't get me wrong. But it's something we want to think about. So this is not the first time you've ever seen these formulas, but just a memory trigger for you. How do you find the area of a rectangle? Well, the way you find the area of a rectangle is you take the base times the height, or the length times the width. So it doesn't matter which one's which, but here's a length and here's a width. So if we were to take the length times the width, it would look like this. But then it does say write an expression. It doesn't tell me whether I need to simplify it or not, but because we've been simplifying today, let's go ahead and simplify it. So this becomes a squared plus a times b. So here's my expression. And then they want me to come back through and evaluate it. Now, there would be some arguments from kids if we were doing this in class, like, hey, can I just plug in like 8 and 3 right now and just do the numbers? Yeah, I'm with you guys. I think that would be easier, actually. But whatever. Since we're practicing evaluating some weird algebra things, let's practice with this one. So instead of a squared, that would be, where's a again? 8 squared. Plus a times b. So 8 times 3. Sometimes you have to approach algebra like, what if I was a robot? What would a robot want to do? Robots don't take shortcuts. They're programmed to do certain things at certain times, right? So we got to remember that. All right, so here is a 64 plus 24, which is 88. And like a good geometry student, I should label this, but they didn't give me labels. Ooh, I moved all my problems. Hold on, go back. Okay, so it is area. I'm just going to say units squared because there's no units. All right, so same idea here. This time it's a triangle. So a little reminder for you, the area of a triangle, because you can envision it as being half of a parallelogram, essentially. It's 1/2 length times width, or 1/2 base times height. They all mean the same thing, right? So half of the length and the width would be like n times n plus 10. Ew. All right, so if I was to, this you got to be careful on, okay? When you're multiplying three things together, you can only do like two at a time, unless you're really, really careful. So maybe I would multiply this together first, and I would get n squared plus 10n. And then I would come back through and distribute the 1/2. We find that when kids try to multiply three things at once, they like over multiply, and then they get it all screwed up. All right, so we got 1/2 n squared plus, now if you do 1/2 times 10, that'll become a 5n. So here's the expression in polynomial form. And they do want me to go through and evaluate if n equals 40. So again, parentheses, parentheses, 1/2. Oh man, this is going to be tough for my brain today. 40 squared plus 5 times 40. Okay, let's see if I'm still on vacation. 40 squared is 1600, and then 1600 cut in half would be 800. And that would be 20 with a 0, so 200. And that would be 1000, right? Units squared. It's really ugly. No, I'm writing on my toy room wall. Not really. All right, so I think that's the end of the lesson. After this, we got some algebraic expression practice, which is probably a sign for you for homework. So please do that in a timely manner. You know, we just did our lesson. Go right into the practice. That's how you learn best. That's the retention factor that we're looking for when you guys are learning algebra. Good luck, and hopefully I don't have to record all my videos here in the toy room, because it's kind of lonely down here. All right, bye.